Hey guys, I figured you all couldn't go another day without hearing my voice, so here I am. Last week we went over section 4, which was properties of logs and change of base formula. Today we're going to start chapter 7, section 5, logarithmic and exponential equations. Today we're just going to go over exponential equations. The notes for logarithmic equations will be posted on Wednesday. With this video, you have a little bit of freedom. You can pause the video at any time if you need to take notes. You can pause the video before a problem so that you can try it on your own before I show my solution steps. You can also mute this video if you don't want to hear my voice. That is not advisable, but the ball is in your court. So let's get started with section 5, logarithmic and exponential equations. Essential understanding for this section: first, you can use logarithms to solve exponential equations, and second, you can use exponents to solve logarithmic equations, so it works either way. Solving an exponential equation with a common base. So we did go over a few of these problems in the beginning of chapter 7. We're just going to do a couple more to review. So first example, what is the solution of 16 raised to the 3x power equals 8. And please bear with me, I'm doing my best to make everything as legible as possible. This is the first time using this program, so as we go on, I'm sure everything will improve. So, back to the problem. What is the solution of 16 raised to the 3x power equals 8? Right now, we do not have a common base. The bases are different. In order to create a common base, we need to think about what number raised to a power gives us 16. We know that 2 raised to the 4th power gives us 16. When you do this, though, we can't forget about this exponent. We still have to raise this to the 3x power equals. So now in order to have the same base on the other side, we need to raise 2 to a power. 2 raised to the 3rd power gives us 8. So now we have a common base, but we still can simplify these exponents here. By the power rule, we know that an exponent raised to another power, we multiply the exponent. So this becomes 2 raised to the 12x power equals 2 cubed. Now we have a common base. Because the bases are the same and these are equal to each other, we know that our exponents have to also be equal to each other. So the equation that we can create is 12x equals 3. Very simple one-step equation. To isolate x, we just have to divide both sides by 12, and we get x equals 3 over 12. But we know we can simplify this further, so fully simplified, we get x equals 1 over 4, and that's our final solution. So 16 raised to the 3 times 1/4 power equals 8. You can check this by plugging it back into your calculator. Another example with a common base: what is the solution of 27 to the 7x power equals 81? If you would like to try this problem on your own, please pause the video now. So we have 27 raised to the 7x power equals 81. We need to get a common base. So let's think about what number raised to the power gives us 27. 3 raised to the 3rd power gives us 27, but we can't forget about this exponent, so we're still raising everything to the 7x power equals. To get a common base, now we need to raise 3 to a power to get 81. 3 raised to the 4th power gives us 81. Before we can create our equation, we have to simplify our exponents. We have power raised to another power, so by the power rule, we're going to multiply our exponents. So we have 3 raised to the 3 times 7x is 21x equals 3 raised to the 4th power. Now that we have a common base, 3 and 3, we're able to set our exponents equal to each other to solve. So 21x has to equal 4. To solve for x, one-step equation, divide both sides by 21, and we get x equals 4 over 21. 4 over 21 cannot be simplified any further, so this is our final answer. So that's when we're able to simplify our terms to a common base. But when bases are not the same, you can solve an exponential equation by taking the logarithm of each side of the equation. What that means is if m and n are positive and we have an equation m is equal to n, then we can solve by saying the log of m is equal to the log of n. So let's look at a few examples. Solving an exponential equation when we have different bases or when we're not able to get our bases to the same number. Our first example, what is the solution of 15 raised to the 3x power equals 285? So we're not able to simplify these bases to the same number. So rather than doing that, we're going to use the rule we saw in the 2 slides ago, which says that we can write log of 15 raised to the 3x power equals log of 285. So all I did here was add log to both sides of this equation. Now, thinking back to the last section, we know by the power rule, we can rewrite this exponent, or power property, we can rewrite this exponent at the beginning of this term. So this becomes 3x log 15 equals the log of 285. Now, for these problems, you're going to need your calculator to solve. So we're trying to find the solution, which means that we're solving for x. So we want to isolate this variable. To get that variable by itself, we're going to have to divide both sides of this equation by 3 log 15. So we have the equation x equals log 285 over 3 log 15. You can plug this into your calculator using parentheses, or to make this a little bit easier, you can first plug in log 285 divided by log 15. Once you do that, you're going to plug in your calculator's answer divided by 3. So either way, you're going to get the same solution. When you plug this into your calculator, you get an x value of approximately 0.696. So our final answer, x is approximately 0.696 after using your calculator to solve. Let's look at another example. What is the solution of 12 raised to the 8x power equals 193? So we have different bases. To solve, we're going to put log in front of each of our terms. So we have log of 12 to the 8x power equals log of 193. By the power property, we know that we can rewrite this exponent in the beginning of our term. So that becomes 8x, So that becomes 8x log 12 equals log 193. Now, to solve, we need to isolate x, so we're going to divide both sides of our equation by 8 log 12. From here, you can plug into your calculator. So if you want to plug into your calculator, you can do log 193 divided by log of 12. Once you solve for that, you're going to take your answer and divide by 8. After you plug in, you're going to get an x value of approximately 0.265, and that's our final answer. The next two examples, you can pause, take a second, and try them on your own. So what is the solution of each exponential equation? Check your answer. So our first exponential equation is 7 raised to the 4x equals 800. The second example is 5.2 raised to the 3x Sorry about that. Raised to the 3x equals 400. So at this time, if you want to pause the video, you can try these two problems on your own. And to check your answer, once you solve for x, you're just going to plug back into the original and see if it works. So for our first example, we have 7 raised to the 4x equals 800. We have different bases, so in order to get it to the same base, we're going to add log to the front of both of our terms. So we have log 7 raised to the 4x power equals log of 800. By properties of exponents, we know that we can take this exponent and bring it down to the front of our term. And we want to do that because we want our variable out of the exponent so that we're able to solve. So when we rewrite this, it becomes 4x log 7 equals log of 800. We're solving for x, so we want to isolate that variable. To do that, we're going to divide both sides by 4 log 7. And when you plug into your calculator and divide, you're going to get an x value of approximately 0.859. To check, you're going to take this x value and plug it back in all the way at the beginning to make sure it works. So 7 raised to the 4 times 0.859 power should give you 800. It might be a little off based off of our rounding, but it should be a value very, very close to 800. For our second example, we have 5.2 raised to the 3x power equals 400. This is a decimal here, don't forget. So to solve, we have different bases. We're going to add log to both of these terms. So log of 5.2 raised to the 3x power equals log of 400. By properties power property, we know that we can rewrite this exponent at the front. So 3x log of 5.2 equals log of 400. We're trying to isolate this variable, so we're going to divide both sides of our equation by 3 log 5.2, 3 log 5.2. When you plug into your calculator and divide, you're going to get an x value of approximately 1.211. To double check and make sure that you solve this correctly, you can plug this x value all the way back in at the beginning of the equation to make sure that it works. So that's just solving with a common base and solving when our bases are different. We're also able to model using exponential equations. And a model with exponential equations, you guessed it, we're doing a word problem. So last slide for today. Our word problem says, wood is a sustainable, renewable, and natural resource when you manage forests properly. Your lumber company has 1,200,000 trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? So we're going to use an exponential equation to model this word problem and solve for how many years it's going to take to harvest half of the trees. So to start, we're going to assign some variables. So we're going to have x equals years and y equals the number of trees. For our exponential equation, we're going to use y equals a parentheses 1 plus r raised to the x power. Remember, a is our initial number of trees. R is going to be the rate of change. We know our rate of change from the problem is 7%. If we're harvesting 7% of the trees each year, that means we're taking 7% of the trees out of our forest. So our R value is going to be minus 7% because we're taking out 7%. Written as a decimal, that's negative 0.07. So if we plug back into our exponential equation, we're going to have y equals, our A value is 1,200,000 because that's the original number of trees that we have, times 1 minus 0.07 raised to the x power. Now, it asks us to solve for how many years. So we're trying to solve for our x value, which means we're going to plug in for y. How many years will it take to harvest half of the trees? So our y value, the number of trees that we want to get to, is half of our original number. So 1,200,000 divided by 2 gives us 600,000, which is our y value, equals 1,200,000 times 1 minus 0.07 is 0.93 raised to the x power. So now we have an equation where we only have one unknown, which is x. To make this into an exponential equation, to simplify it a little bit more, we can divide both sides by 1,200,000. When we divide, 600,000 divided by 1,200,000 gives us 0.5 equals 0.93 raised to the x power. So now we have an equation that looks very similar to the problems that we were looking at before, but we have different bases. If we have different bases, we know that we're able to add log to both sides of this equation. So we have log of 0.5 equals log of 0.93 raised to the x power. Our exponent here is x. By the power property, we can bring that down to the front. So this becomes log of 0.5 equals x times log of 0.93. To solve for x, we want to isolate our variable. So we're going to divide both sides by log 0.93 divided by log 0.93. When you plug this into your calculator, log of 0.5 divided by log of 0.93, you're going to get x is approximately 9.55. So, how many years will it take to harvest half of the trees? It will take approximately 9.5 years. Well, that's ugly. 9.55 years. And that's our final answer. So that's it for today on exponential equations. On Classroom, there is an assignment posted so that you can try some of these problems on your own. Also, there is going to be an exit ticket posted that you have to complete. Everything is due by 11:59 tomorrow. I will also post that on Classroom. Continuing, if you have any questions, please reach out to me. Feel free. I will answer as many questions as I can. During school hours is the best time to reach me. Outside of school hours, I check my email and Classroom, but not as frequently as I do during school hours. So please keep working. Do not hesitate to contact me if you have any confusion. And good luck. Have fun.